Guys, I've got another super exciting blockchain tutorial for you today. I'm going to show you how to create a blockchain-based image sharing website just like Instagram where you can earn cryptocurrency for posting. And it's going to be a super advanced Web 3.0 application because it's going to be powered by the Ethereum blockchain and also ipfs, the interplanetary file system. So it'll be censorship resistant and unstoppable. And at this point, if you're thinking like, whoa, like I don't even understand anything you just said, that's okay. Hang with me. Basically, the main idea is that we're going to recreate Instagram on the blockchain, and it's going to be better because we use blockchain in the process. And you'll see why in this tutorial, all right? And don't worry, you don't have to be a programmer already or understand anything about blockchain in order to follow along. I'll show you everything step by step. I'll show you how to create Ethereum smart contracts with the Solidity programming language, how to write tests for them, put them on a blockchain, and then I'll create a client-side application with React.js that will take these images, put them on ipfs so that we can put them on the blockchain. So before we get into that, if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash the like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step by step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. So here's a quick demo of the app that we're going to build today. This is a decentralized Instagram clone called Decentragram, where you get rewarded for creating great content. So you can upload pictures in a decentralized way, and then other users can tip your images with cryptocurrency. And the best images will be curated at the top of the newsfeed. So this is going to be completely powered by blockchain and also ipfs, which is a decentralized file storage system for uploading images. So this will be a completely unstoppable application powered by Web 3.0. Here's a quick diagram of how the application will work. So let's first look at how Instagram works. So whenever you use Instagram, you access it with a mobile device, and this mobile device talks to a back-end web server. This is where all the code, all of the data, and all of the images for the application lives. And whenever you request the images to your timeline, this data is served back from the web server to your mobile device. This is how many mobile applications are built, but it has a few major problems. The biggest problem is that the application creators have full control over which content gets shown to their users. Social media is notorious for its algorithms, and one of the biggest problems with these algorithms is that they can effectively censor users on the platform by hiding certain content and also surfacing specific content that the application creators think is best for their users to see. So we don't want to build an image sharing website in this centralized way that's prone to this type of manipulation. We want to build it in a decentralized way with a very different, straightforward, transparent algorithm that's free from censorship. So I'll show you what that looks like. So instead of having a mobile application that talks to a web server, we'll have a blockchain-based application that you access with a web browser with a blockchain wallet, and it'll talk directly to a website written in HTML, CSS, and JavaScript. And then this website will talk directly to the blockchain, where our code will be written in Ethereum smart contracts deployed to the Ethereum blockchain. And then all of the images will get stored on a decentralized file storage system called ipfs. So the images can never be censored or taken down or anything like that. And this will be a fully transparent algorithm we know works the same way every time because the smart contract code is immutable. It cannot change, and users can go verify how it works by reading the code. Now let's install the dependencies we need for this tutorial. The first dependency is Node.js. This is going to allow us to install all the packages on our computer as well as run our client-side application. So you can see if you have Node already installed by going to your terminal and typing node-v. So I'm using Node 9.10.0. I would recommend using the exact same version for best results during this tutorial, but you can probably use the latest version if you really want to and you know what you're doing. So you can download Node directly from the website, or you can use a command line tool like Homebrew, a package manager to install it that way. The next dependency is the Truffle framework. This is a framework for creating Ethereum smart contracts. We can write Ethereum smart contracts with the Solidity programming language, write tests against them, and deploy them to a blockchain with Truffle, as well as many other things which you'll see in this tutorial. You can install Truffle from your command line like this, say npm install --g truffle at version 5.1.39. The next dependency is the Ganache personal blockchain. This is a blockchain that will run on our computer. We can simply download it and run transactions in the blockchain, deploy smart contracts to it without having to pay any real money. So go ahead and download Ganache. You can just click the version for your operating system here. And whenever it's finished downloading, you can open it and you'll see that you have a brand new blockchain running on your computer just like this. You'll see lots of different accounts funded with 100 fake Ether. And don't get too excited because this isn't actually worth anything. The last dependency is the MetaMask extension for Google Chrome. Most modern web browsers won't connect to the blockchain out of the box, and so we need to install a special browser extension to do that. That's exactly what MetaMask does. It's an Ethereum wallet that turns our browser into a blockchain browser. So go to the Google Chrome Web Store, find MetaMask, and click install. And once you have it installed, you should see a Fox icon in the top right-hand corner. And just walk through the setup steps to get that started. Now let's start coding the project. Go to this GitHub link down in the description below. This is the final code solution for the project today. So this is Dapp University Decentragram repository. And we're gonna clone this to get started so that we don't have to set everything up from scratch on our computer, but we're gonna start off on a very specific branch with the starter code, not the final code solution. So you can do that like this, say git clone -b starter code. That's a very specific branch. And then you can just copy this link here and then paste it into your terminal and then give it a project name. So I'm just going to call it Decentragram and hit enter. All right, there we go. And then we'll enter into that newly created directory like this. We'll say cd Decentragram. All right, and now you'll see the project here on a very specific branch, the starter code. So now we can install the dependencies for the project like this. We say npm install. All right, now those are finished installing. And the next thing we want to do is make sure that we have Ganache running. So Ganache is our personal blockchain that we, installed during the dependencies section, but you want to make sure you open that. So this is the test blockchain that we're going to use for this tutorial series. And it makes it really nice because we can spin up a blockchain on our computer without having to spend any real money. Again, whenever you use a blockchain in real life, you have to spend actual cryptocurrency. So we can just get 10 accounts here for free that all have 100 fake Ether in it, right? Because this is an Ethereum blockchain that we've set up here on our computer. So it'll have some fake cryptocurrency in here. It's not worth anything. Don't get excited. But that makes it nice and easy. So we'll push our smart contracts for this tutorial to this specific blockchain. So we need it running here, all right? So next we want to do is open up a new tab here in our terminal. And I'm going to go ahead and start the web server just to ensure that everything is set up properly. I'm going to say npm run start. This will be the client side portion of the application. So let's see here, that's my old demo. This will probably go away whenever I refresh. So let's just check the status here. It usually takes a second. All right, there we go. So here is the cleared out version. So this is just the starter code that just doesn't have anything wired up inside of it. It just has the basic nav bar up here with our Decentragram name, a place for our Ethereum account, but it's blank here at the moment. That's okay. And then the instructions to edit this file in app.js. So let's just take a look inside the project code to see what was created for us. So I'll go back to this tab and say subl dot. So this just opens the code inside of my text editor. I personally use Sublime Text. You can use whatever text editor you're most comfortable with. Whatever you prefer is just fine. But inside of here, well, actually really quickly, sometimes people ask me what this subl dot means. It's just a shortcut that I have configured on my computer that opens the code in Sublime Text. It's not required for you in this tutorial. If you want to open, your code some other way, that's totally fine. That's just how I do it. So let's take a quick look here. So let's look at the instructions. So edit this file in app.js. So in the source directory, we see source components app.js. This is the starter code for the project here. All right, so you can see all that. And then let's look at the blockchain portion. This is all the client-side application, but we also have a place for our smart contracts. So source contracts, we have a Decentragram smart contract here. It's blank. We'll fill in the code for that. All right. And then the other place to note is our test file. So we'll write test for the smart contract inside of here. All right, so we'll clear some of this out. It's okay. And then finally, we have the, let's see here, the truffle configuration file. All right. So this is truffle.js. If you have a naming conflict, you could also call this truffle-config.js. We'll just go ahead and do that. So we'll say truffle-config.js. Okay. So I just want to rename that file. Sometimes there's a naming conflict on different systems, so that's what it does. And you might notice if you've done other truffle projects before that these directories are in a different place. That's okay. I just put the smart contracts and the build files in a different directory because they get exposed to React better when I do it this way, when I organize the code in this specific way. All right. So let's go ahead and get started with the blockchain portion of this. Let's go ahead and write the first smart contract. Let's test it out to make sure that it works properly. And then we have the environment set up that we can actually start coding out the rest of the application, right? So we'll go to source contracts, decentragram, and this is where we're going to write all the code, all the business logic for the app in Solidity, all right? So that's what this is. This is a Solidity smart contract. That's the main programming language used to write Ethereum smart contracts. It's pretty basic. At the top of the file, we have Pragma Solidity version 0.5.0. This is just the programming language version. And then we have the contract keyword, which just tells Solidity that we're writing a smart contract. And then we give it the name decentragram here. And then all the code will go inside these curly braces. So the first thing we want to do is just set a variable name. We'll say string public name equals decentragram. All right. So what this does is it uses a basic variable in Solidity, which is a state variable, meaning that it belongs to this entire smart contract. Variable is just a way to store information. And the value of this variable is this string, decentragram. A string is just like any arbitrary collection of, keyboard characters that are contained inside these little quotation marks here. So it could be like a word, it could be a phrase, it could be a password, it could be lots of different things. So this is just a string. And this string gets stored on the blockchain because this variable is a state variable, okay? And we see that it is a string data type here, all right, because Solidity is a statically typed language, which means that we have to tell it what the data type is whenever we define a variable, all right? And then, the data type can't change. It can't be a number later or anything like that. And then finally, we call this public so that we can read the value of this variable outside the smart contract, which we'll see in just a second whenever we do it in the console. All right. So let's go to the terminal and say truffle migrate. And I'm just going to go ahead and do the reset flag. All right. Actually, that's going to fail. So I'm going to stop this really quickly. It's going to fail because we didn't actually create a migration file. So that's actually the next step. I've made this mistake before. I've made it lots of times, and I've caught myself doing it in this tutorial, and I'm going to leave it on the film because, it's good for you all to see what the errors are, because they happen whenever you're creating your own projects. So if I try to do this, it wouldn't work because we didn't create a migration. So go to this migrations directory and look at this file, number 2, deploy contracts. So what this file does is it puts smart contracts in the blockchain. That's what the migration files do inside of Truffle. They move the smart contracts from one place to another. They migrate them from our computer basically to a blockchain. All right, it compiles them down. It puts them in a machine readable format for the blockchain so that they can be run and executed that way. Okay, so this file looks just like the default migration inside of Truffle. So this default migration just puts this migration contract on the blockchain. That's the one that determines how all the other smart contracts can be deployed. Don't worry too much about that. This just ships by default in every single Truffle project. But this one is created specifically for the tutorial. So like if you created a new Truffle project on your own, you wouldn't see this deploy contract in here. You'd have to create this yourself. But I've already created it as a boilerplate for the tutorial, so we don't have to do everything ourselves, okay? So we imported the decentragram smart contract into JavaScript right here. All right, so artifact required decentragram. All right, and now we just deploy it to the blockchain like this. We'll literally just take this line, copy it from here, put it inside of here, and change the name. All right, and then it deploys the Decentragram smart contract to the blockchain. And now we go back to our terminal and say truffle migrate -- reset, and then it'll work. So a quick note here, I'm doing the reset flag in case you happen to have any old smart contracts inside your project already. I typically run with the reset flag in development a lot just by default. All right. So that looks like it worked. Let's see if it worked. We can go to the terminal and say truffle console. This will open up a JavaScript runtime environment where we can interact with the blockchain. So we can write JavaScript commands to fetch our smart contract, to interact with it, to read information from the blockchain, all that kind of stuff. So we'll just go inside of here and say Decentragram equals capital D Decentragram dot deployed. All right. But before that, we want to say await. Okay, so it's undefined. That's okay. But we're going to type Decentragram. And there we go. Awesome. So it's worked. So let me explain what I just did. You'll scroll back up here and see Decentragram equals await Decentragram.deployed. So what we've done is fetched Decentragram from the blockchain. That's the smart contract we just wrote. And we assigned it to a variable. But there's a few things to note here. This is an asynchronous function call. So we need this await keyword in order to get the result. If we didn't have the await keyword, it would just return the promise, not the actual smart contract itself. So I've talked about this a lot on my channel. Asynchronous programming can be a little bit confusing. So if you want to understand more about that, just Google how promises work with JavaScript and also like how the async await pattern works, okay? So anyways, you get the value here and you'll see that it's undefined. That's just the value that gets logged to the console. It's not the actual return value. So just type in Decentragram again, and you'll see the actual JavaScript version of the smart contract here, okay? And that's what that is. So we can say Decentragram.address. All right, boom. There's the address in the blockchain. So smart contracts have addresses just like users do on the blockchain. It's sort of like the smart contract's username. It just tells us where this smart contract is located on the blockchain. So that's the address. And then we can get the name like this. We'll say name equals await Decentragram lowercase d dot name and then parentheses. All right, so it's going to say undefined, but then we just type in name again to the console. And then boom, there we go. Decentragram. Awesome. So we have successfully read this variable value out of our smart contract. Okay. Say source contracts. All right. So we've made this work. Awesome. Very cool. So that's it. That's the first smoke test to see that, we've opened the project on our computer. We've started the blockchain. We've talked to the smart contract in the console, all that kind of stuff. So that's looking good. The next thing we want to do is continue on coding out this smart contract, but we're going to do that with the help of some tests, okay? So instead of like going to the console and doing these steps over and over and over and over again to like test out the behavior, we're going to automate that process. We're going to speed it up. That's what we use tests for. So basically we can write tests in JavaScript to this test directory. So look at this test.js. So it looks like all the tests are already in here, but we'll clear these out and write them by hand. But instead of writing every single one out by hand, let's just clear out, these. Let's take out this. All right, just take out the describe images part, okay? And then we'll just run the basic test because that way we don't have to code that from scratch. So this particular tutorial, we'll spend less time setting up this test. If you want to look at more, testing examples, I've done that plenty in my other tutorials. But let's just start off with this boilerplate where we just check for what we just did in the console. This is literally the same thing, just translated into tests. So if you go to Mocha and then Chai. So the Mocha testing framework is what comes bundled default into Truffle. So that's what allows us to write smart, tests for the smart contract in JavaScript. And then also the Chai assertion library lets us do that too. It lets us do things like, foo should be a string, chai should, which is exactly what we're going to use in this tutorial. So you'll look at this like Here's chai imported, right? And then this like contract decentigram is what, is basically Mocha in action, where we can write tests for the smart contract. We write these describe functions. We write these assertions inside these it functions. And so we're doing basically what we just did in the console, but inside a JavaScript test, and it's going to speed things up. So we write this first test example. We say it deploys successfully. All right. And then we get decentigram, just like we did in the console here. We store it to this variable value. And then we say address equals await decentigram address. And we could say assert not equal, address. We don't want it to be blank. So we check to make sure it's not the empty address, that it's not a blank string, and it's not null or undefined. And that's going to tell us that the address exists because we don't necessarily know what it's going to be. And then next, we just check that the name is actually decentigram, just like we defined in the console. Okay. So let's run that test like this. So we say truffle test. All right, there we go. It passes. Awesome. So that's going to show you how we can, make sure that the smart contract works while we're coding it out, because we'll build the back end first before we code out the front end. So basically, we'll write all the code for decentigram inside of here. And then we'll write tests to make sure that that code works. And then once we're sure that it works, we'll go ahead and code out the front end part of the application. So another important thing to note here is that testing is, it's important for a lot of different pieces of software, but it's particularly important for smart contracts. Here's why. Smart contract code is immutable. It means it cannot change. That's the whole point. And so whenever you put a smart contract on the blockchain, you want to make sure that it works really, really, really well, because you can't change it, once you've deployed it. All you can do is deploy a new copy of it, all right? And so it's extra important to test your smart contracts and make sure that the behavior works, because once you've put it out there in the wild, there's really no going back. And so that's what we'll do in this tutorial as we write the tests while we write the code here. So before we start coding out the rest of the smart contract, let's do a quick review of how it's going to work. So remember, we're going to connect with our web browser and a blockchain wallet to the website, which we'll code out in the next section. But that's going to talk directly to this blockchain smart contract, okay? And what this smart contract is going to do is hold all of the posts, right, the social media posts that contain images in decentigram, okay? But the images themselves are actually going to get stored in ipfs, right, which is a decentralized file storage service, okay? And those ipfs images, they just have hashes. So sort of like our smart contract has an address, right? It's very similar on ipfs. They have hashes that tell us where the file is located, which is very similar to the address like we have on the blockchain, okay? So what we're going to do is basically just whenever we create a new post, we're going to store the ipfs hash or kind of address, right, on the blockchain itself. So the blockchain won't actually host any images, because that would really be cost prohibitive. I mean, you have to pay a ton of cryptocurrency to store that much data on the blockchain, and we don't want to do that. So we want to put an ipfs and then store the ipfs hash on the blockchain itself, okay, with the smart contract. And then the smart contract will be responsible for listing out the posts, and then also creating new posts, and also tipping posts in the newsfeed, right? So that's what we'll create in this coding section. So first we need to, store posts. We need to create posts. And then we need to tip posts. And I guess these will really be images, so I'll just rename that to make it, more self-explanatory, less confusing, I'll say. So let's start off with storing images. So we created this, variable here with a string that's just the name of the smart contract. So very similarly, we want to create a storage mechanism, kind of like a database for storing these images, or at least the hashes of the images that come back from ipfs. So we're going to use something called a mapping inside of Solidity to do that. So let's just look at this up. So here's the Solidity documentation, and then you can see the mapping data type here. So a mapping is just a key value store, which basically means that it just takes a key with a certain data type and a value, and this acts like a database. So the key is kind of like an ID, and then the value is the data that actually gets stored in the blockchain. So you can see that in action here. You can read about it more in the documentation if you'd like. but it looks like this in Solidity. So we'll say mapping. All right, so uint, and then here's the value is image. All right, we'll create that in a second. Public images. All right, so this is how we're going to store the images. All right. So this mapping, like I said, it's like an associative array or, a hash table in other programming languages where it has a key, and this key is just going to be a number. It's going to be like an ID, all right? And then the value is going to be the actual image, which I'll show you in a second. It's going to store the reference to the ipfs hash, and this will be public. We can read it outside the smart contract, just like this decentragram string, and we're going to call it images, all right? So the image is not created yet. We're going to use something called a struct for this, all right? And I'll just go ahead and show you like this. Boom. Structs are really cool because they allow you to create your own data types inside of Solidity. You can define any kind of arbitrary data that you want to, and that's exactly what we're going to do here for our images. So here's a struct that we've created. We just call it struct, and then we use the struct keyword, then we call it image. So that's the image here, all right? And we can give it any arbitrary values we want to. So uint here is just an unsigned integer. So I don't think I explained that a second ago. Basically, unsigned means it has to be a positive integer, or basically it just doesn't have a zero, it doesn't have a minus sign in front of it. So like -7 would be a signed integer. It has a sign in front of it, right? But an unsigned integer does not. So basically it just can't be negative. Anyways, so it has an ID, which has to be non-negative. Is a string is the hash. This is the location on ipfs. The string will have a description for the post, right? So you can, create a body for it. An unsigned integer for the tip amount. So we're going to tip cryptocurrency, and this will store how much. And then the address of the author so that we can send them the tip, all right? And so that's the image struct that will go here, all right? So again, this is a mapping, works like a database where you have an ID for every single image, every single post in the newsfeed, all right? And then this will be the value that's stored in that database, quote unquote. This will be this arbitrary image. It's kind of like defining a table in the database, or these will be the columns, right? With the ID, the hash, the description, the tip amount, and then the author. And then it's going to get stored in this public variable images, all right? And when we do that, Solidity will basically just give us a function for free called images, all right? And that way we can call the images function outside the smart contract in order to fetch all of the images, okay? So I know that's kind of a little challenging to understand without seeing it in action. So let's go ahead and create an image, all right, with a function, and this will all make sense once we start writing it in the test. It's a lot of ground to cover initially, but just hang in there, bear with me. We'll create this, and you'll see it in action, okay? So let's just create a basic function to create the image. So we'll say function upload image. All right, and then I'm not going to get too fancy here. I'm really just going to create a basic function, public. And then inside of here, I'm going to add a new image to this mapping here so you'll see it in action. This is not the final function code. It's just going to show you how it works so that we don't like keep coding for a long time and you don't see it in action. So we add new images to the mapping like this. We'll just say images, and then this is an unsigned integer, so we'll just add 1 the first time. So we'll say, image, the first one will be ID image 1, all right? So images number 1 is equal to a new image, okay? And we'll give it just an ID of 1. We'll give it a hash. We'll say ABC123, all right? And then a description. We'll say hello world. And then we'll no description, no tip. And then for the author, we'll just say 0x, we'll say address 0x0. All right. So we'll see if that works. So now what we're going to do is write a test to create this image. Let's just see if it works. All right. So we'll create a new testing block. We'll say, instead of describe deployment, we'll say describe images, and we'll say async. All right, so again, this is an asynchronous function call. So let's go ahead and put some variables in here. We'll just say let results, and then we'll create another before. Well, let's just do this. We'll say it creates images. All right, we'll say async. I'll bump the font up here so you can see a little better. Creates images. And then let's call that function. So we'll say result equals await decentragram. Say upload images, or let's just say upload image. So make sure I got the function name right. And then let's just see what happens. And then actually let's do this. Results. We'll say let image equals await decentragram images, and then we'll read in 1, and then we'll console log image. All right, take away these. All right, so let's try to run that test and see what happens. It might fail, but let's give it a try. So truffle test. Oops, sorry, I forgot a T there. Truffle test. So this is not a complete test. I just want to show you this in action. All right, so it didn't fail. It didn't blow up on us either. Okay, so I wrote this test to show you what's going on so far. So here's what we did. We called this upload image function, okay, which we coded out here, which stores a new image in the mapping. So we'd have this images function, right? And this images function is what's, we have this image mapping here that we reference directly. We use these open and close brackets to write a new value to this. So we say images, and then the key of 1, just the ID of 1, the first image, right, ever created, will be a new image, and that's how we create a new image. You know, we create an image struct, all right, with this capital image word right here, and then we do these open and close parentheses, and we pass in the arguments. So the ID is 1, the image hash from ipfs, this is just a demo hash, abc123, the description of the image, so hello world, the tip amount will be 0 for now, and then the address of the author is just a blank address. I just do address 0x0 to show you what the possible values are, and that it works, okay? So we call that function inside the test, and then I did this to illustrate how the image mapping works. So we call it images, but when we call it public, Solidity gives us a function for free called images that we can read outside the smart contract like this, decentragram images, all right? And then what we do is, this doesn't actually return the entire image mapping. That doesn't work. Solidity doesn't work that way. When you use this function, you have to call out each individual image by passing in the ID, all right? So we can't call images and get all the images. We have to access them out one by one. So we know that the first one exists because that's the one we created. So we just pass in 1, it returns that image, and then we log it to the console here, which we can see in the test. So here's the results. Here's the ID is 1, it's just a JavaScript big number. The hash is this, description is this, tip amount is this, and then the author is this. Awesome. So that's how it works so far. That's the really basic, bare bones implementation for creating images. Now we're going to expand this out and code it out a lot more, but I wanted to show you that how that basic functionality works before we make this more sophisticated. All right. So let's keep going. We'll create the rest of this function, and then we'll write some more advanced tests for it. So instead of just hard coding in this ID here, what we want to do is actually generate IDs dynamically. So every time this function gets called, we want to create a new ID instead of just saying 1 here every time, okay? So we're going to use something called image count, all right? So just above this mapping, or just let's do it below. Well, let's do above. I think it's better organization. We'll say uint public image count equals 0. All right. So what we'll do is use this to generate IDs. So every time this function gets called, we'll take this image count and add 1 to it, and we'll use that as the ID. So just above this, we'll say adds images to contract. We'll say increment image ID. So we'll just say image count. We could do this plus, we could say this image count plus 1, all right? That would basically add 1 to the images every single time. But we have a shortcut in Solidity that does the exact same thing. We just say image count plus plus, and that increments it by 1. And then we can use this image count to as the ID for the mapping, okay? So yeah, you can see what happened. We had image ID 1, but the first time this function was called, the exact same thing would happen. It would start with 0, and then when we call this function, the image count would get incremented by 1, and you'd have this would now be equal 1, and then, you know, we create an image with the ID 1 with these values, okay? And then every time, the next time the function called, this will be 2, the next time it'll be 3, the next time it'll be 4, and so we'll have an ID management system built into our smart contract with this variable value and then this line here, all right? So boom, that's awesome. That's the next major step. So after that, we want to generate these values dynamically. So first we need to change this and say image count. All right. And then we want to let users set these values. So whenever they upload their image, we'll say string memory image hash. Okay. So instead of these are function arguments. So these are just arbitrary values that can get passed into the function. So the image hash is what will come back from ipfs after it's uploaded. It'll just be a string. So it could have been ABC123, or it could be the actual ipfs image hash. And then we'll say the description. So string memory description. And then we'll pass this value in here. Boom. And so you'll notice that I use underscores here. That's because I just do that as a convention to differentiate between local variables that are passed in as function arguments, all right, and then these state variables. So I don't use underscores for state variables like this, but I tend to use underscores for these function arguments like this, just as a general rule. And I don't always follow that rule, but that's my general rule. And so still, the first time we create this, we'll say 0 tip, all right, because we don't want to generate a tip whenever the image is uploaded. But we do want to set the author of the post dynamically. So how do we do that? Well, Solidity has a global variable called message, all right, so let's just clear this out. It's called message, abbreviated by MSG. All right, so you can do MSG anywhere inside any function, and it represents the global message that's coming in with the Solidity transaction, or sorry, the Ethereum transaction. And it has a few values on it. One of them is MSG.sender, okay? And so MSG.sender or message sender is the person who's calling this function. It's their Ethereum address. All right, so we saw, the Ethereum address here. This is the author. It's a blank address. This will actually be the real Ethereum address of the person who's calling this function whenever they upload the image, all right? So that'll be the author, and it'll get stored here, okay? So boom, there we go. That's how we dynamically upload an image inside of the smart contract with this function. So next, let's actually just, yeah, let's write a little more code before we write tests for this, okay? The last thing we want to do is create an event for this. All right. So Solidity allows us to create events that let us know that things happen on the blockchain. I know we're covering a lot of ground inside this, but it'll all make sense when we see it in the tests, and we'll also repeat a lot of this information whenever we write the second function. But let me just show you really quickly. All right, so Solidity, let's look at here, events. Like I said, just hang with me. I think this will all make sense. Let's see here, looking at the documentation. All right, so let's see here, events. Solidity supports these events that let us know that things happen on the blockchain. So let's see here. You can create your own events like this inside Solidity, and you can subscribe to them externally in your application. Witness the activity on the blockchain. So basically, we can create an event every time this function is called that lets us know that an image was uploaded, and we can inspect all the values that happened whenever the image was uploaded. And we could get like a push notification on our phone or something like that. We can see the entire event log stream, which basically shows us the entire history of this function call on the blockchain. So I'll show you how that works. Basically, we'll define an event a lot like this struct here, because you can define arbitrary events just like you can define arbitrary data types with structs like this. Boom. So we say event image created, that's the name. All right. And then we pass in the values for the event. And you'll notice these look suspiciously like the values here. That's because they're the exact same thing, right? So we just store the ID, the IPFS hash, the description, all right, the tip amount, and then the author, okay? So we can trigger this event with a single line at the end of this function like this. Boom. We just say emit image created, just like this. Boom. And then we say image count, image hash, description, 0, MSG sender. So it's the exact same arguments that get passed into the image struct, get passed in down here whenever we trigger the event. All right. So with that being said, let's go witness some of this in the tests so that I'm not just coding all day without seeing how this stuff works. I don't want it to be too abstract. I want you to witness it in action inside the test. So let's go back to the test file, and then we'll continue on building out this test example. All right. So let's move some of this logic up to a before function, just like this. Okay. So it's going to look like this. All right. So inside describe images, above it creates images, we'll do this. Boom. So we'll say before async, and we'll say decentragram upload image. So just like this, we actually want to pass in, the function arguments. We'll say hash. So we need an IPFS hash. All right. And we'll just, boom, we'll do it like this. So you can pass in anything you want to. Let's actually just say like ABC123, just so that you all can replicate this on your own machine and you don't have to have the exact IPFS hash. Okay. And then we'll do the hash here. And then let's just say, image description can be the image description. And then we pass in some metadata here. So like this would be the function arguments, the two arguments that we define. But then if you put a comma here, you can pass in a JavaScript object to provide the function metadata. All right. These are not actual function arguments. They're just the function arguments in JavaScript that simulate who calls the function inside the test. So basically, like we say from author, this is just telling Solidity who the function caller is. All right. So author is coming from up here. All right. So these are the accounts in the testing scenario. We have a deployer, we have an author, and a tipper. Okay. So the deployer is the person who deployed the smart contract. All right. The author will be the person who creates the posts, and that's who we're sending this function. That's who's sending this function right here. Okay. And it's important to know that the author is going to be translated to message sender here inside the Solidity function. All right. So The person who's calling it is the author, and then that translates to message sender inside the smart contract. Okay, so then next we will get the image count. All right, let me just clear this out. So we'll say Decentragram await Decentragram image count. All right, and then we'll need a place to store the image count like this. So result and then image count. All right. So now we'll code out the creating images part. So we'll say success. We'll say assert equal image count equals 1. All right, because remember, whenever we increment this function, the image count is public and it should now be 1 after the function's been called. And then we'll say const event equals result dot logs. Actually, let's just do this. Let's just ensure that the count is right, and then let's console log the results to see it in action. I think it'll make more sense that way. All right, before we run the test, I realized that I made a little bit of an error in the Solidity code. Basically, we need to take this out. All right, so sorry about that. I just overlooked that while I was talking and recording at the same time. It happens. Sometimes it's difficult to think and talk at the same time. It's easy to miss your mistakes. So let's do this, save that. All right, then go back to the test and say truffle test. And now this should work. So let's give it a whirl here. And boom, there we go. So it works, and it also deploys the result. Sorry, it logs the result to the console. So you can see here, the image count does in fact equal 1. That's what we expect, right? So the image count was incremented properly after I fixed this line of code. All right, image count. And then the result was logged to the console. And here you can see that the result of the function call has all this data inside of it. It has the transaction hash that was triggered on the blockchain. It has the transaction receipt. And then inside of that, it has the actual values from the event. All right. So you can see, like, here's the event itself. And then these arguments have like the name and all that kind of stuff. So we could say like result. Let's just run it one more time. Say logs. Okay, so you can see the logs here. Okay, and then this is an array. This is an array here. And then we'll say logs. We'll read the first item out of it. All right. And then we'll say, we'll look for this args argument here. Say args. All right, and then log the console like this. Oops, sorry, trouble test. And then boom, there we go. So here's the actual event that comes back. You can see it has an ID, a hash, a description, a tip amount, and an author. So that's why we use the event, is so that we can see like the data that comes back. You can see the ID, the image hash, the description, the tip, and then the author. And that's all these values logged to the console here. All right. And so now we can dig into that event. We can do this. We can just say event equals that. So say boom. Const event equals result logs, the first one, 0 based index array, and then args. And then we can just assert that all the values from the event are correct. So we can say assert.equal event.id, to number equals the image count, all right, that the ID is correct, that the hash is correct, all right, so event.hash is the hash, event.description is image description, right, which is what we put in here. That the tip amount is in fact 0 because, we haven't issued a tip yet, and that the event author is the same as the author that called the function here, okay? So let's just do shuffle test. Let's see what happens. All right, boom, it passes. Perfect. So the next thing we want to do is finish off this function. All right, we're almost done. We got to create one more function to tip the owner, but we'll finish off this last part. We want to add some requirements to this function. Okay, so basically, like for example, we don't want people to, we We don't want people to upload blank images here. We don't want people to upload blank descriptions. All right. And we don't want, invalid senders to like put data on the blockchain. So I'll show you how that works. So Solidity has these things called require. All right. I'll show you in the documentation here. So basically just like safeguards. So we can create something called require. So the function like this, all right, we could say like, require is basically a function and that it has some sort of expression inside of it. And if that expression evaluates to true, then the function will continue execution. And if it's false, it'll halt and it will revert and none of the code below it will run. Okay. So let me show you what that looks like inside our code. So you could say something like, require, 1 plus 1, equals 2, and then say, yay, it's true, or something like that. You know what I mean? And if not, say, bad math. So basically this is going to value to true. And if it's true, the function will continue execution. And if it's false, it'll stop and this, error would come up or something like that. Okay. So we're not going to add a message necessarily, but you could just say like require true. And the function, if I just left this line here, the code would keep running and this would never get triggered. But if I said require false here, all right, then the code would stop execution and this code would never run. And so you can make that more complicated. Say 1 plus 1 equals 2. This would always execute. If I did this, this would never execute. And so now we can make that more complicated and say, require bytes description length is greater than 0. Boom. So what that does is make sure that this is never blank so that they can't create, a description that is an empty string. It's basically requiring that the image always has some sort of body post to it, like some sort of description whenever they upload it to the Decentragram social network. So what we do is take this, convert it to bytes, a different data type than the string, because we can determine the length that way. So we say bytes description, length is greater than 0, all right? And we'll just say, make sure that the image description exists. And if it doesn't exist, this code will halt execution and none of this code will run right here. It's just a safeguard inside the function, okay? So similarly, we want to make sure that the image hash exists. So we don't want a blank ipfs hash to get uploaded to the blockchain. So I say boom, require bytes image hash length greater than 0. And then finally, we want to ensure that the person who's uploading this, all right, is not the blank address. So we do this, boom. Require msg.sender or message.sender is not equal, so blank, so bang equals address 0. So this is the empty address. We could say address 0x0 to make it, clearer. So also notice this bang equals is the opposite of equals. So basically it means that like not equals. So we always want to make sure that the message sender is not equal to the empty address. Okay. So basically it's just validations. If you've done other software development, validations on a database or validations inside of a function. So make sure that the image hash exists, make sure the post description exists, and then make sure that a valid uploader it exists. All right. So now we can write tests for this. That's our complete function. We'll just write a few tests to check for the failure. So the first thing we'll do is say, we'll try to upload it with a empty hash, and we'll reject it inside the test like this. Boom. Say await Decentragram upload image with a blank image hash. All right. And then we'll do it from the author. And then we say should be rejected. All right. That's how we do it with the test suite here. So we say should be rejected. All right. So let's run the test. Truffle test. See if it works. All right. So creates images. Boom. Done. All right. And then next, we want to ensure that it uploads, it fails with blank descriptions like this, boom. So do Instagram, upload image, image hash, blank description. All right, so from author should be rejected. So if there's no description, then it should fail too. So write a test and then run it, see what happens. And then boom, it fails. Awesome, perfect. I mean, it fails, it doesn't, we check for the failure, I guess is what I'm saying. You'll see a green test, which is what you expect, but the test is green because, you know, we caught the failure message here and ensured that the failure indeed happened. Okay, so boom, done. All right, so next, let's write a basic test to show you how the images get listed out on the page, because this is what's gonna happen on the client side. So basically, like, we'll write this block that just says it lists images, okay? Because it's important to understand how that works. So like, we'll do this, boom. So we'll say it lists images, all right? So it creates images, it lists images. So like when we want to create a news feed, for an example, we have to fetch all the images, all right? So what we'll do inside of here, we'll say const image equals await decentigram images image count, all right? So remember, we did that inside the first test where we read out the image, all right? And what we want to do is actually, you know, write that in a test so that we can always run it later, okay? So we'll just dig into the struct values like this. We'll say assert equal image ID to number, all right, is the same, that the image hash is correct, the description is correct, and the author is correct. Just like the event here, but inside the, inside that struct. Write truffle test. All right, boom, it passes. And so the last thing we need to do here is write a function to tip the author, okay? So we're gonna move a little bit faster on this because we've explored all the basic Solidity, you know, concepts in this first function, and we're gonna move a lot faster in the second function because we have a lot of ground to cover to create the front end application for this as well, okay? So we're going to create a function called tip images, or sorry, tip image owner. Tip image owner. All right, I'm going to do this. All right, it's a little too much. Tip image owner. And this is basically just going to accept the ID of the image. It's going to be public, and it's also going to be payable. All right, this is important to know because we're going to actually send cryptocurrency in this function call whenever we tip the image. And you have to use this payable keyword right here. In addition to public, if you want to send cryptocurrency whenever you call the function, all right? Okay, so let's write the basic behavior in here. Basically, what we want to do is fetch the image from storage, all right, like this. We'll say image memory image, all right, equals images ID. So see how we created a new image like this in the previous function call. We said images image count, all right, and then we created a new image like this. Well, similarly, we can just like, you know, read the image out of the mapping like this. So underscore image equals images, then pass in the ID from the function. But then we have to give it the data type, which is image, right, which we defined here. And we say that it's memory because it's not an image from storage. So storage is on the blockchain. This image is just a local variable in memory inside this function call, okay? So next we want to do is get the image author. So we can just read it off of the struct like this. We just say, you know, image author. And then we want to pay the author. So we'll store it to a variable. So we'll say fetch the author. All right. And then we want to send the cryptocurrency from this function call to the author. And it's pretty simple. All we have to do is get the author and call this special function, all right, inside Solidity called transfer. Say transfer. And then we could say, you know, like some amount of cryptocurrency. We could say like 1 Ether or something like that. Boom. All right. So that's how you send cryptocurrency inside of a function. You use this special transfer function because this is an address. And in fact, we're going to be explicit here. We'll say address. All right, author. So this address here, comes off the image. And we'll say author. And then we transfer some amount of cryptocurrency to this. Now, I just use this one Ether as an example. But let's actually use the cryptocurrency that came in when this function was called. So just like we had msg.sender here, this message.sender, message is, like I said, is a global key. It's a global variable, but it also has another value called value, right? And that it references the amount of Ethereum cryptocurrency that's sent in, or Ether, whenever this function is called. Okay, so message value is the amount of cryptocurrency that's sent in when this function is called. And so we say transfer message value, the amount of cryptocurrency that's sent in, to the author that came in from this image. All right. So we'll say, pay the author by sending them Ether. Okay. So that's critical. Okay. That's the critical line of this whole function. Tip the image owner. That's the biggest part, is actually sending the tip to the image. So basically what happens is, the Ether comes in with this function call, and then it gets passed on to the author directly right here on this line. And then finally, we need to update some values on this image before we put it back in the struct. So we'll update the tip amount, all right, like this. We'll say increment the tip amount. So image tip amount equals image tip amount plus message value, right? That's what was sent in here. We'll update the image like this, put it back in the mapping. All right. So basically, we fetch the image out, we read the author off the image, we send the author Ether, we update the tip amount on the image, and then we put the image back in the mapping after we read it out. All right. So boom, that is the core functionality of this entire function. There's a few steps left, but that's the basics. Read the image off the blockchain, find the author, send the author the tip, update the tip amount on the image, put the image back in the blockchain. All right. And so finally, we're going to emit an event just like we did here. So we're going to do an image tipped event. All right. Like this. So image tipped. So ID, hash, description, tip amount, author, just like this, exact same arguments. We will emit that event at the bottom. All right, so after this, say trigger an event, image tipped, ID, image hash, image description, image tip amount, and then author, okay? And then lastly, we will make sure that the ID is valid, because we don't want you tipping the wrong image or an image that doesn't exist. So let's do this. We'll say require that the ID, all right, is greater than 0. All right, that's essential. And that the ID is less than the image count. All right. So the image count, if the image count is 10, then the only valid image IDs are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Sorry, image count. Because it can't be 0 and it can't be bigger than 10. So if you try to tip ID, 99, then this function call would fail. If you tried to tip, function 0, it would fail. If you try to tip -1, it'll fail by default because it's an unsigned integer. Okay. All right, so that's the complete smart contract. Now, I know I moved kind of fast on that second function, but there's a lot of ground to cover, and we saw a lot of the fundamentals, in the first function. All right, so let's write a quick test for this second one. All right, I'm actually just going to go with the test from the final code solution. So you can find this down in the description below. I'm just going to paste it in. So I don't really have time to go through all this one by one, but I'll walk you through how it works. So first of all, what we do is track the author balance before the purchase. So what we want to do is make sure that the author receives the tips, okay? So here's the old author balance. So we use this Web3 ETH get balance. That's how you find the balance of the author, all right? And then we say the result, we call the function, so Decentragram tip image owner. So you pass in the image count, all right? We want the latest image. And then we use the function metadata from tipper. That's a different account, just like we saw previously, all right? And then here's the next thing you need to understand is value, message value. Here's how you determine message value. So just like in this previous function call, this is how you determine message sender is with the from keyword. All right, remember message sender? Well, in this case, you want to do message value, which is this right here, which is the amount of cryptocurrency getting sent in when you send the tip. And that's how you do it right here, message value. Okay, this is the message. So the value here, we're going to use the Web3 library, Web3 utils 2-way and 1 ether. So basically we're sending the author 1 ether or 1 Ethereum cryptocurrency basically, but we have to convert it to this thing called way. All right. So that everything, Ethereum doesn't work with decimal places. Like, so smart contracts don't handle decimal places. That's why we do these like unsigned integers. So everything is stored in basically like whole numbers or unsigned integers in this case. And so like way is like Ethereum's penny, for example. So like, you know, 1 penny, 100 pennies equals $1 US, for example. But like ether, 1 ether equals 1 followed by 18 decimal places. All right, way. So that's how they get around working with fractions for cryptocurrencies. You use these really big numbers at the smart contract level so that you don't work with decimal places. So you always convert your ether values to way whenever you're sending cryptocurrency around like that. And that's what this helper's for. So Web3 utils 2-way and then 1 ether. All right, so we want to send 1 ether. All right. So anyways, we send it. We check that the result is correct. All right, so it emits the event just like we did in the previous test. And now what we want to do is check that the author balance has gone up. All right, so we say check that the author balance receives funds. All right, and that the new balance is actually bigger. Okay, so we'll start off there, and yeah, there we go. Old balance, add tip image owner. All right, and then the new balance is what we expect it to be. And then finally, we check for the failure so that it won't tip image number 99 and that it'll be rejected anytime that happens, just like the rejections that we did up here. So let's clear this out, run the test and see if it passes. Hopefully it should work just fine. All right, boom, it works. All right, so that is a complete smart contract with tests. I know we moved kind of fast on that last portion, but again, we spent more time on the basics on that first function and the first test. We got a lot of ground to cover on the front-end application. So now that the back end's done, before we move on to the front end, let's just make sure that we've compiled our smart contracts and deployed them to the blockchain. So we'll say truffle migrate -- reset. So I'll re-explain what that reset flag is for. Remember, whenever you deploy smart contracts to the blockchain, you can't change the code. You can only deploy new copies of them. So that's what we do whenever we use the reset flag, okay? And yeah, I do it here because we already deployed one version of the smart contract to the blockchain, but we have now changed the code. So that's why I use the reset flag to put a new copy on the blockchain, the complete version, and it tells Truffle where it is to update the address and all that kind of stuff. So boom, it worked. And now we have the complete smart contract that we're going to use to start coding out the client side part. So let's do that now. All right, so now let's start building out the client side application. So you need to make sure to go to your terminal and ensure that the web server is running. So you can just do npm run start and a new tab if you want to. I'll just show you. So npm run start. All right, that should reload the application here on your client side. I'm going to keep it in a separate tab, terminal tab, so that I can work with the code in this side. All right. So, go ahead and open up your text editor and navigate to the source directory and then the components directory and then app.js. So this is going to be the main file that we modify initially to build out the client side portion. So this code right here is, it's JavaScript, but it's written in React.js or written with React.js. So I'll explain that. React is a JavaScript library for building user interfaces. So it's a modern web development framework. It's very popular in the blockchain community. That's one of the main reasons I teach it, but it's popular for a good reason. It's a well thought out JavaScript framework. Solves a lot of the common problems that you encounter whenever you're creating JavaScript client-side applications or user interfaces. So React's a component-based library, which basically means that you organize all of your code into React components. It has a state object, which basically is like a little mini database for the front end. So that's where we'll put all the blockchain data. When we hydrate our application, we put it in state. So a pretty good example of that is like this to-do list right here. We know what is state. So if we say item 1, and then like item 2, where do those items go? Well, they go inside the React state object, which you can see here. This.state equals this with items, all right? It's got some special functions for interacting with that state, which we'll see in this tutorial. So the big things to note are, components, which are these, the state, which is this. This is where the blockchain data will go. And then lastly, the components are basically, you can mix HTML code and a JavaScript code together in the same file. That's how the components work. So you see this like render function right here. Well, this lays all the content out on the page, and you can put HTML code right here, but then you can remix JavaScript code inside of here with these curly brackets. You can just say like this.props.name, all right? That's JavaScript inside these curly braces. We'll definitely see that in action inside this tutorial. Okay, so the best way to learn React, honestly, if you don't know it, is to just watch along and code along with the tutorial. That's like how I learned these types of things initially when I was first learning programming, was just like, just watch it being done and do it over and over again, and then it'll start to make sense, okay? So there's three components that we're going to work on in this tutorial. So this app component, this is the main component. All right. And then, like I said, components are how we organize the code. So you'll see it's got some HTML inside of here to this render function. There's another component already inside of here called the nav bar. Okay. So the nav bar is, this code right here with the little camera icon, the title, and then also the blank Ethereum address here. And that nav bar code is inside this file here. So nav bar, boom, we'll edit this. And let's see here. The nav bar is also imported at the top of this file. So that's important to note. Anytime you create a new component, you have to import it like this. And then lastly, we have this main component. All right. That is here. All right. And we'll also put code inside of here. You can see that this, edit this file inside of app.js. That's the main content, which is here. All right. So app.js governs like the whole app. The nav bar is up here and the main is down here. And it kind of makes logical sense. You use components for organizing your app code based on logical groupings. So the logical code for the nav bar goes in the nav bar file. The logical code for the main component goes here. Okay. All right. So let's start wiring this up. All right. So the first thing we want to do is actually connect the application to the blockchain. And in order to do that, we're going to use the Web3 library. So let me show you the Web3 library. Let me pull that up here. So Web3 is the main JavaScript library for interacting with Ethereum, and that's the one we're going to use in this tutorial. Okay, so you can see, Web3 here. We'll use this a lot, but here's the documentation. So we're going to use Web3, but it's important to notice that we have to do two things. We have to turn our client-side app into a blockchain app. That's what Web3 does. But then we also have to turn our web browser into a blockchain browser in order to connect with this. And that's what metamask does, okay? So metamask is an Ethereum wallet, all right, that turns our browser into a blockchain browser. Again, that's what we installed the dependencies, and that's what's on this diagram here. So this is metamask, which works in tandem with our web browser to talk to this HTML portion, which talks to the blockchain. So we've built this part already. Now we have to build this part that talks to the blockchain, and then also ipfs, all right? First, before we actually wire up Web3, we need to import our account into Ganache. From Ganache into metamask. So basically, you'll open Ganache, wherever that's running. You'll find the first account in the list here. You'll reveal the private key. So don't actually use this private key in production, all right, because everyone who's watched this tutorial will have seen it. So click copy, and then go to metamask, go to your accounts, and then go to import account, paste in the private key, click import. I've already done it, so it won't do anything. But once you do, you'll see your account connected here with Ganache. You might need to refresh the page, but you should see your Ether balance, all right? Yeah, you can see that the Ether balance has actually gone down. That's because you have to pay Ethereum and gas fees, or Ether cryptocurrency and gas fees, right? Whenever you put the smart contract on the network. So remember, anytime you write data to Ethereum, you have to pay gas fees because transactions cost money. Writes to the blockchain cost money, but reading information from the blockchain is totally free. So if anybody wants to get on Decentragram and just look at pictures, it does not cost them anything. But if you want to put new pictures on Decentragram, then you have to pay money to do it. And then, of course, if you want to issue tips for them, then you also have to pay money to do that. So Truffle uses this first account in the list as the deployer account, and so it deployed the smart contract to the blockchain already, and that's why the balance has gone down. But it also used it to simulate the tests, and so that's why this balance has gone up. So this is the person that received the tips, I guess, or maybe this is the person who is this is the author, this is the tipper. So yeah, these are the first three accounts in the test scenario. That's why these balances have changed. So sorry, that's kind of a little bit of a tangent, but yeah, so we've edited, so we've imported our account into Ganache. Let's go ahead and import another one. Let's just import this second account. All right, boom, it's Ganache number 2. So repeat that process because you want 2 accounts in here because you want an author and then you also want a deployer, okay? So go ahead and do that. Author and a tipper because we don't want to tip our own posts. So we'll get back to that later. All right, so let's go ahead and wire the application for the blockchain. Inside of here, we want to create a function for doing that. So first of all, we have Web3 imported at the top of our project already, right? So that's good. And then we want to load Web3 like this. I'm just going to paste in a function like this, boom. So load Web3. Now, don't worry about coding this out step by step. I don't code this out step by step in my own projects because it's literally just a copy and paste. This is exactly how MetaMask tells us to import Web3 into our projects, and I've just adapted it for this tutorial, okay? So don't worry if you don't even understand all of this. Basically what it does is it gets the Ethereum provider from MetaMask, okay? MetaMask is going to put an Ethereum provider into our browser to allow us to connect to Ethereum, and it just uses that Ethereum provider to instantiate a connection to the blockchain with this line of code right here. So basically it looks for window Ethereum, or if that doesn't exist, it looks for window.web3. And if it doesn't find that Ether, it tells us, hey, like you don't have a Ethereum-based browser, you should try installing MetaMask, okay? So don't stress if you don't understand that, okay? But now we've defined this function. Now we need to call it. So I'm going to use a special function in React called component will mount. So this is just a lifecycle function. So basically, this is a magical function provided by React that React always knows what to do if we define this function. Basically, before this render method gets called here, it's going to run this code. All right. So React has a lot of different lifecycle callbacks. You can go read about those if you want to. But basically, we'll just do this. Inside of here, we'll say load Web3. All right. So we'll go back to our page and just make sure that nothing is broken. I've opened the console down here. You could just do like inspect. All right. Then go to console if you want to. That'll show you how to use this. All right. And then now we've loaded our connection to the blockchain. Now it's actually load up the blockchain data. So I'm going to make a special function here. I'm going to name it Let's just call it load blockchain data. All right. And then we'll also call it here. So after load web3, we'll do this load.blockchain data. All right. And what we'll do here is we'll just fetch the account from metamask and then log it out to the page. Okay. So inside Web3.js, let's look for accounts. So this is how we'll actually get the accounts from Web3. So we say Web3 ETH get accounts. And this is just going to expose all the accounts from MetaMask into our app. So we'll just call that function inside of our code like this. We'll say const accounts equals await Web3 ETH get accounts. All right, just like we saw in the documentation. So we assign it to a variable. All right, and then we can just log that to the console. Say console.log accounts. And then we'll actually just do the first one. So accounts 0. So accounts is an array. All right, we'll just do it. So we'll just look at that first without the value. All right. And then we see it in the console right here. All right. So it's an array. And here's the account that we're connected with inside of MetaMask. All right. So you can see that here. All right. Boom. It's the exact same one. 2AEC, 2AEC. All right. Perfect. So now what we want to do is actually store this value inside the React state object. So remember, inside of React, we have this state object just like we did our to-do list, right? So we're going to create our own state, our own kind of database, so to speak, on the client side to keep some information in there for the app, and we're going to store the account in there. So, React tells us to create a default state object like this. We use this constructor object. So this is just a function that gets run whenever the component's created. Constructor is a special keyword here, all right? So it tells us how to do it. And then it has this.state is just this JavaScript object, all right, with the default state inside of it. So we do the exact same thing in our app right here with constructor, all right. This is just like the React documentation, but then we define our own custom state. So the account is blank in this case, but we want to update this value, all right, because, you see the account's blank, and then whenever we are inside of our app here, it's blank right here, all right. So we want to say accounts equals await Web3 get accounts. All right. And then, but we want to update the state to update this value right here. So we say this set state, and then we say account, and we say accounts 0. All right. So remember, accounts is an array, and we can fetch the first account like this. All right. So we'll say this.set state. We'll go refresh the page and see what happens. All right, so boom. Now, we don't see an address here yet, but we do see a little identicon, which is pretty cool. All right, I'll explain that here in a second. So let's trace this logic, all right? So we've set the state with the account, and then you'll notice that the nav bar, when it's rendered, it has a variable called account, okay? And the account is set equal to this.state account. So this is how we write to the state object with the account. And this is how we read from the state object with the account. All right, so this.state.account. All right. And then this account gets passed down to this navbar file, all right, which you see here. And this is a lot of code already, wired up inside of it. Again, all this HTML inside of here. You see all this extra styles and stuff. We're using the Bootstrap templating framework so that we don't have to write a bunch of HTML and CSS code ourselves. All right, that's what all these extra classes are for. It's for the Bootstrap framework. Okay, but you'll notice that you'll notice this line here. All right, so the ID account, instead of 0x0, we want it to be this.props.account. All right. And save that and go back to the page. And then boom, there we go. We can see our account from MetaMask listed here. All right. So basically, let me show you how that works. So the account is passed in here. So account is the variable value. It's actually the component props. That's what it's for. Props just stands for properties. So we define a custom account prop here. And then inside of the component, we read it out with this.props.account, which is just the same name that we arbitrarily defined here. Okay. So awesome. Now the nav bar is wired up and we can see our ID there. And that is powered by the special Identicon library. So let me show you that. Identicon.js. That's just this file here. You can create a fancy image here just from arbitrary data. You can put your name in there. You could say foobar. But what we've done is basically taken it and put in our Ethereum address, and then boom, it creates data like that. So it didn't actually use our entire Ethereum address. I guess it has a limit on how much it can actually do. But you can use, this is not the same library. Let me actually look it up here. Identicon. Yeah, this is it right here. But you get the idea. It's the same idea. But these are the Identicons that we have. So basically, you just have this special code, all right, that passes in the Identicon, or passes in the data for the Identicon, and it generates that image automatically. So it's not the same library that I showed you with that demo, but it's the same idea, all right? And then here's all the code that just does it. So if you want to copy and paste that for your own apps to use your own Identicon, it's just using the Identicon library from the package.json file. We've already installed it here. Just make sure you do npm install Identicon.js, all right? And then import it into your component, and then render it out on the page just like this. And we just pass in the Ethereum address, all right? So that's how that works. Boom, done. So we have connected to the blockchain. We have added in the account. So the next thing we want to do is get the Decentragram smart contract from the network. So I'll show you. We go to source. Let's see here, ABIs, Decentragram JSON. So this is a special file generated by Truffle. It's not really an ABI. That's not the best name for this directory, but it's the same idea. The ABI is inside of here, all right? So the smart contract ABI is basically just a JSON representation for how the smart contract works. It describes the types of functions that the smart contract has. So for example, the ABI tells us that the smart contract has an upload image function and that it requires these arguments. It tells us that it has a tip image owner function, right? And it requires these arguments. That's what the ABI does, okay? And then it also has an address, which is the location of the smart contract on the blockchain. All right, so you can go all the way down to the bottom. You can look for networks, all right? And then you can see the address here, okay? So what we're gonna do is create a JavaScript version of the smart contract with Web3.js. So let's just look at the documentation here. We want to use this Web3 ETH contract, okay? And we're going to create a new smart contract like this. So we'll just create a JavaScript version of the smart contract so we can call the functions inside the app, like fetching all the posts, tipping the posts, etc., etc. So we'll say Web3 ETH contract, and it requires two arguments: the JSON interface, which is the ABI, and then the address. So both of those pieces of information that I just showed you in that big file, we need both of those to create a JavaScript version of the smart contract with Web3. And so we need to dig those out. All right. So basically inside of here, let's just say like, let's do this. Let's say like, this is the final destination we want to go to. Const Decentragram equals Web3 ETH contract, and then Decentragram, or just say we want ABI and then address. That's the final destination we want to go to, but there are a few steps required in order to do that, okay? So the first step is we need to find the ABI, all right? So the ABI is contained here, all right? Well, sorry, it's contained here, all right? This entire file just has the ABI right here. So this entire thing, ABI, right? And you'll notice that the top of this file, we've imported it, all right? So we've already imported Decentragram from ABI's Decentragram.json. That's this right here. So we've already got that, the ABI. So we can just say Decentragram.ABI. But the address is a lot trickier, okay? Because, let's see here. I don't know why this decided to move it into anything, but anyways, the address is trickier because the address is nested deeply into this file under the networks key, okay? Because the smart contract can be deployed to multiple blockchains, multiple blockchain networks, but we want to find the specific address for Ganache, okay? You'll notice that Ganache has a network ID of 5777, all right? So you can see this 5777 is the name of the network here, all right? And that's the address you want to get, because, you know, if it was deployed on the main Ethereum network, this would be like 1, right? If it was a test net like Kovan, for example, it could be like 42, but we want this specific network. So we need to get the network data for the particular network, right? And then find the address. So I'll do that kind of fast, but I'll show you how it works. So basically, go back to this app.js file, and then we'll say the network ID, we can get it from Web3 like this. Network ID equals await Web3 ETH get, or sorry, net get ID. That'll return 5777 from Ganache. And then we want to get the network data, which is, you know, this network key right here. And then we want to pass in the 5777, all right, like this. So network data equals Decentragram networks network ID that we got back here. So this is going to be 5777, right? So basically we're just reading out that file, finding that, but instead we get it dynamically here. All right. And then we say, like, you know, if, you know, network data, okay, and then else, all right. This is the if-else statement. Then we want to get the address. And so the network, the address is just available on the network data, all right? So, boom. So here's the ABI, and here's the address. And the address is assigned dynamically based on the network. We fetch the network, we get the data out, and then we instantiate the smart contract with the ABI and the address like that, all right? So, and if that doesn't work, then basically we're going to create an alert that says, you know, the Decentragram contract has not been deployed to the detected network. So we can just check that out in our browser. Go back here, and then boom, no errors. But if like we switch to the main Ethereum network here, or sorry, let's do main Ethereum network or Ropsten test network, doesn't matter. Boom, Decentragram contract not deployed to the detected network. All right, so it works. All right, but we want to go back to Ganache, and now we should no longer see that error, and awesome, there we go. So we have successfully connected the smart contract to our app. It's running inside of there. And then now what we want to do is hydrate the app with all the data from the smart contract. So what we want to do is load all the images for the timeline. All right. And well, actually first, we're going to do that, but first we need to store the smart contract into the state. So for this default thing here, we're going to say, after account, we'll say Decentragram is just null. And let's go ahead and fill out the rest of this state. We'll say images, it'll just be an empty array. This is going to be all the images in the timeline. All right. And then we'll say loading, we'll say just true. All right. So we're going to see a loading flag there, but that's okay. Let's go refresh, and that's what we expect. Boom, it's going to be loading. That's all right. All right. So I'll explain that in a second, but we just fill out the state, so we don't have to come back and do this. So what we want to do is populate this. So that'd be pretty easy. We'll just say this, you know, set state, and we'll do it right here. This set state Decentragram, we can say is Decentragram. So we did that just like we did here. But the cool thing about ES6 is if we have a key and a value with the exact same name, we don't have to do this. We can just do a shortcut like this. Boom. So that's the exact same thing. And then now what we want to do is actually load up all the images in the news feed. Okay. So first thing we want to do is get the image count. All right. So image count. All right. So basically we do Decentragram methods image count just like we did in the test. But since we're using Web3.js directly, we have to say call here. Okay. So, you know, with Web3, let me find the documentation here. Anytime you're reading data from the blockchain, you can't just call the function. You actually have to do the call function on it. So basically, like methods image count, you can't just do that. All right. If you want to actually get the image count, you have to do call. All right. Boom, like that. And similarly, if you want to create a transaction, you have to do send, which is, yeah, we'll see that in action whenever we actually create new posts and tip them. All right. So next, we're going to update the state with the images count. Oops, sorry, like this. Boom. Say the set state images count. All right. Now, before we continue, I actually want to change gears here because I don't want to continue building this out until we've actually created an image. And I kind of want to show you how ipfs works with this application. So we're going to pause here. We'll come back to this. I want to show you how to actually create an image. So before we actually list the images out on the page, because I think it'll make more sense that way. Okay. So first, let's like create an image. Okay. So we're going to do that inside the main component here. So we'll go to this, let's just see here. I don't have it open yet. Okay, here's the main. So inside of here, what we're going to do is actually create a form for uploading a new image, all right? So I'll just start off with some template code like this. You can find this in the final code solution, but I'll just put it in here for now to kind of make it easier. All right, so we'll take away this, edit inside app.js file, and then we'll take all this out, and then we'll replace this code with this form. All right, so this is in the final code solution if you want to find it there. But I'll show you how this works. So let's just go refresh the page and see if it works. So loading. One more thing here. So before we do that, let's go back to our the main.js, app.js file. Okay. At the bottom, let's just do this set state. We want to actually make the loading done. This set state loading false. So I know I've jumped around quite a bit here. I'll explain what's going on. All right, boom. So basically what's going on is like, we see that loader flash, all right? So basically we want the app to be loading while the blockchain data is loading up. So that's what this loading is here. By default, whenever the app boots up, we want loading to be true. But then once we've loaded all the blockchain data, we set loading to false, and that's just managed with the state object, all right? And you can see the logic here on the page. So say this.state.loading. So if it's true, that's what this little ternary operator does, this question mark, then we show this loader right here. So that's if the expression evaluates to true, we show this. If it's false, then we put in this other component, the main component. So if it's loading, show the loader. If it's not loading, go ahead and show the main component, which is all the code down in here, okay? So, yeah. That's what's going on there. And I just updated that so that we're not just showing the loading page. But now when you see it, here's the form, boom, for sharing the image. All right. So I'm going to move through this part kind of quickly, but just so you can see how it works. Basically, we just, upload an image here. All right. So it doesn't work just yet, but you could click this to expose some images. So let's see how it works. Basically, it's just an HTML form, and it has this input here, all right? And it accepts these specific file types. And so it has two inputs, really. One for the file here, all right? And then one for the image description. So I'm going to actually bump this code over to make that a little more consistent, all right? So let's do this. Actually, this is better. I meant to do this. Yeah, so input for the file, and then an input for the description. So I want to focus on first and foremost uploading the file to ipfs, all right? Because it's a two-step process, all right? So step one is going to be we upload the file from our browser here, from our desktop or wherever. And whenever we do this, we need to process the file so that it can be uploaded for ipfs, okay? And then it's going to get captured by ipfs and then put on the blockchain. So it's a multi-step process. Basically, whenever you choose the file, it's going to get pre-processed, and then whenever you submit the upload, it's going to get put on ipfs. Once it comes back from ipfs, it'll get put on the blockchain. So let's actually write all the code for that. So go back to app.js, all right? So first thing we want to do is create a function called capture file, okay? So just below load blockchain data, we'll do that. All right, we'll create this function like this. We'll say capture file equals event. All right, so it should be a function, right? Arrow function here. First thing is the event prevent default because we're going to submit a button. We don't want it to refresh the page. And the first thing is we'll read the file, okay? So this is how you do it off the event. We say event target files 0. This is just reading the file off the HTML element, all right? And then the file reader is just going to be the native window file reader from JavaScript, and then we read it as an array buffer. So basically what this does is it just allows us to pre-process the file so that it can actually be uploaded to ipfs. So basically it takes the image file from our computer and it converts it into a format that the ipfs uploader expects, all right? So basically, whenever it does that, we just set state buffer equals buffer reader results, all right? So it converts it to a buffer object, and that's what we need in order to upload to ipfs. Don't worry if you don't understand everything inside of here. That's just what has to happen, okay? So basically, we can take that capture file, all right, and then pass it into the main component like this. And so we can say, capture file. All right, capture file, this dot capture file. And then inside main.js, you'll see that on change, whenever this input is, done, then we will capture the file like this prop.capture file. All right. And then it'll get pre-processed for uploading. And so now I'll just upload a file to show you how that works. So I'm going to click this choose file button, and you can see here that it's logged to the console. So this is what the array buffer looks like. Don't worry if you don't understand this. Like I said, this just pre-processes the file so that it can be uploaded to ipfs. And that's all this code does here. And you can see the logged value out to the console. All right, so it's working. So we've captured the file. All right, we've pre-processed it basically. And now what we want to do is actually create a function for uploading the image to ipfs and then also the blockchain itself. All right. So let's do this next function like this. Boom. We'll say upload image. All right. So it's another function that is going to accept the description. But here's what we want to do. Here's how it goes to ipfs. So basically, we just do ipfs.add. All right, this.state.buffer. All right, so that's what we set here. After we pre-process the image, we loaded it to state. And then basically, if there's an error, we'll log it to the console. And then if there's not, we'll actually say we're going to load it. And then we're going to say this.state.decentragram, methods upload image. And that's actually going to call the smart contract function. Okay, load it to the blockchain, and then add the description that was created whenever we passed it in from the form, and then we send it from this .state.account, and then whenever the transaction hash comes back, we'll set the state loading to false. Okay, so that's a lot. I know we skipped a lot ahead there. Let's just ignore this part for now. I'm just going to comment it out. Let's just upload the file to ipfs because we don't even have this ipfs thing added yet, all right? So don't worry about the smart contract part yet. Let's just get the image actually on ipfs. So we need to set up an IPFS connection, which is really easy. All right. So in our package.json file, we have an IPFS HTTP client. All right. If you go to the package.json file here, you can see this IPFS HTTP client. All right. All we have to do inside this app.js file is import it like this. Let's say const IPFS client equals require IPFS HTTP client. And then we can use the default one for Infura like this. Boom. IPFS equals IPFS client host Infura port 5001 and then HTTPS. So don't worry if you don't understand all that out of the box, but that's just how you connect to IPFS for free, really easily inside the app. So now we can call methods like, IPFS add, and then put the file in it like this. All right. And so let's just add a file, log at the console so you can see what happens before we actually put it onto the smart contract on the blockchain. Okay. So we need to pass that down to the component here. So just below capture file, we'll actually do upload image. All right. So now you can see when we click submit, we have an on submit handler here that does this upload image. All right. And it passes in the description. All right. And then that's how it'll work. So let's just give it a try. Refresh the page here. So got a little issue. Let me just fix this really quickly because he's bugging me. So this is telling me that you can't use class. So line 32 inside of main. So on line 32 here, let's do this. So let's change this to class name because React doesn't let you use the word class because it's a conflict. All right, so that's gone. All right, so let's actually upload it. So I have selected an image. Of course, we've seen this array buffer here. Let's give it a description. We'll just say, hello world. Upload to IPFS. And you can see that it is submitting to IPFS. And then, boom, it comes back. So here's the IPFS result, which is an array of objects. But then it actually, it returns the hash, all right? So that's the real world IPFS hash that we're going to store on the blockchain. So we have successfully uploaded an image to IPFS. In fact, you can just look at it like this. So let me just pull this off screen. Let's see, IPFS IO. All right, let me just see here. Let me show you what the file looks like on IPFS before we actually try to read it out on the inside the project. So let's see here. Yeah, we can do it like this. So basically, we can use the Infura URL. So we just say like IPFS Infura.io. Okay, and then we say IPFS, pass an image like this, and then boom, there we go. Awesome. So that's our image that we just uploaded. So you should be able to see yours like that. So let me show you how I built that out. So here is the image hash. Okay. All right. And then we prepend the image hash like this. So boom, ipfs.infura.io/IPFS, then pass it the image hash. And that's what we just uploaded. Okay. So you'll see this in action here in a minute whenever we actually put this inside the smart contract in the blockchain, but I just wanted to show you before we got there. All right. All right. So now what we want to do, finish that part up. All right. So let's see here inside of app.js, we actually want to put that IPFS hash onto the blockchain. So remember, we got the hash back whenever we uploaded the image, and now we want to put that on the blockchain. So we set loading to true. And then we'll uncomment out this line. So we'll say this.state.centigram. This is the smart contract. We'll do methods upload image. All right. So here's the result 0 hash. Okay, that's what this is. Result 0 hash. Okay. And then we'll pass in the description. So that's going to come from this text box right here. All right. and then we'll say send from this state account, all right? And then whenever that's finished, we'll set loading to false. So remember, inside Web3, we have we did the call functions. So like whenever you read data from the blockchain, you call a function, you say call at the end. For whenever you're actually creating a transaction and you are, putting data on the blockchain, you're making a transaction, so you call send at the end, and then it accepts these options, and we pass in the options, which are a lot like the metadata we saw inside the tests. So this is from, okay? So from this .state.account, all right? So let's give it a try. And then let's just see. I think that's everything. Let's just look at main.js. So on submit, upload the image. I think that'll work. Let's just give it a try. So I've chosen my image. It came back. And we'll just say, hi, Vitalik. All right, so submitting to file to ipfs. It came back. And then here we go. Awesome. A metamask confirmation pops up and says, do you actually want to write this on the blockchain? We'll click confirm. And now you'll notice that you'll see the gas settings here. So remember, whenever we write data to the blockchain, we have to pay money. And that's what we're doing here. This is the gas fee. You have to pay gas fees in Ether, the native currency of the Ethereum blockchain, whenever you write new transactions. And that's what we're doing. So we click confirm to say, yes, we want to pay money to do this. And boom, there we go. Confirm transaction. We'll refresh the page. And it worked. So we don't see any confirmation that it worked because we're not actually showing any images on the page yet. So let's do that next, okay? We will, we'll go ahead and list out all the images on the page like this. We'll do that kind of fast because we need to move this along here. We've been going for a while. I want to go ahead and wrap us up today. So come really far, congratulations. But there are a few more other things we got to do. So we're going to go back to where we left off with when we were filling in this load blockchain data. So inside of here, we've already got the images count. So now what we want to do is loop through all of the images with JavaScript. So JavaScript for loop is what we want to use. So you can see how a JavaScript for loop works is basically if you have an array, then you can loop over each item in the array. So this example is an array of cars, all right? So, or there's a string. They're doing a string here. We're going to do an array, don't worry. Let's just see if they actually use an array example. Yeah, looping of an array. So here's a cars array. And so basically they says like, I guess you could do for X of cars, or you could do the old school way. We're going to do the old school way just because... Yeah, we're just going to do the old school way. So we'll do a for loop like this. You'll see how it works. So we say load images. So we say for I equals 1. So this will be the first ID. Say images count. That's the total number of images. And then each time in this loop, we're going to increment the count by 1. So say image equals await decentragram methods images, just like we did the tests. We pass in the ID, which is going to be 1. And then we say call, right? Remember, we get to do call. Read data from the blockchain. And then we're going to update the state with the images like this. We take the existing images, we use the ES6 spread operator, and we pop the new image in, right? So boom, there we go. And then the last thing we want to do, well, yeah, that'll work for now, okay? So we'll load up the images, and we will list them on the page. So then we want to pass in the images here. So we'll say this .state.images, pass that down to main.js. And then we want to put in the code that, we'll put in the code that shows the images on the page. So I'm just going to paste this in from kind of code solution. So I want to spend all day on this particular part. Again, I want to make this more about the blockchain part of this rather than like all the front end stuff. The front end's important, but understanding how the blockchain part is more important. Understanding how the blockchain part works is more important. So, and also, if you want to learn a lot of this stuff more in depth, you can definitely do that inside the bootcamp. I'll put a link down in the description below. So what we're going to do is take this .props.images, which we passed in. We would call the map function, which just loops over all of them. And then we basically list out each image onto the page like this. We put in the author with their identicon. All right. We put in the image description that was created. And then finally, we put in the image from ipfs like this. We just put in this URL that I showed you in the web browser a minute ago, pass in the image hash, all right? And then we have a button at the bottom that allows them to tip the posts, okay? So the tip amount is always going to be 0.1 Ether. It's a fixed amount, okay? So always like you just tip 0.1 Ether anytime you like a post. So liking is tipping in this case. And then, yeah, we tip the image owner. So that's going to be a function that we'll create in a minute. But that's how it works. So let's look to see if we can find our post. And boom, there we go. Awesome. So, so we have another conflict here though. So line 51. So let's change this to class name. All right, get rid of this error. And then boom, there we go. Awesome. We can see our image that we uploaded first. All right. So yeah, there we go. Boom. Let's go ahead and add another image. All right. So I'm going to choose another file off screen here. All right, recent. I'm going to upload my own image. Okay. And then I'll tip up, I'll say, hello world. All right, click upload. And then MetaMask confirmation pops up. Click confirm. All right. Boom, there we go. Awesome. Boom, awesome. Yeah, we have two images in the timeline now. All right. So now what we want to do is allow users to tip these posts, okay? So we've created the feed, we've uploaded them to ipfs, and let's actually change accounts here in MetaMask. So go ahead and open up your MetaMask and switch to the different account in the list. So to switch accounts. I'm going to do my second Ganache account here. All right, so I just done that. Off screen, you can see, just click on this and you'll see your accounts come down, and then scroll down that list and find your second account. Here's mine. So I've got some more Ether in here. And now I'm going to interact with this so that I can tip another person. Okay. So we haven't done that just yet. So let's go to the code. This is the last part. Inside app.js, we're going to create a tip post function. All right. And so it'll look like this. We'll say tip image owner. All right. And this will be, all right, it has to be async, I don't think. Let's see here. Let's just do this, ID, and then tip amount. All right. And so this is going to be the function that actually calls that method on the smart contract. So we did this in the test already, so this should look pretty familiar. So we'll set the state loading to true, and then we'll say this.state.disintegram methods tip image owner. All right, that's the smart contract function name. We just pass in the ID. We say send from the current account, and then the value is gonna be the tip amount, which is passed in from this function, which is set elsewhere. I'll show you that in a second. And then when the transaction's finished, we'll set the state loading to false. Okay. So we need to pass that function down to our main component. All right, like this, boom, tip image owner. All right. And then inside of main.js, we say we have the tip image owner function already wired up on this button. So on click, we do a hard-coded tip amount, and then we say tip image owner event target name, and then tip amount, and we call that function. Okay, so boom. So let's give it a try. And so now I'm going to very specifically tip this image. All right, the most recent image, not the first image, because you see these don't have any tips yet, but I want to tip the second one for a very specific reason, okay? So you'll see the MetaMask confirmation pop up. You can see the tip amount. All right, click confirm, and then boom, there you go. And then refresh the page. All right. So now you'll see the tips is 0.1 ETH here, and this one doesn't have any Ether yet. All right, so the tipping worked, and the last thing we want to do is actually curate the news feed so that the highest tipped posts go to the very top. So it's going to flip-flop the order of these images if we write the code correctly, and that's the last thing we're going to do. All right. So basically, we're just going to sort the images at the very last line, like this. Well, so here, inside of load blockchain data, right before the loading part, say boom, sort images. Show highest tipped images first. say this set state images, this set state images sort. This is just a function in JavaScript that sorts the array. So A and B. So B tip amount minus A tip amount. So the highest tipped post shows up first. All right, so boom. Save that. Go back to page, and boom, there we go. Awesome. So the highest tipped post goes to the top. So that's it, everybody. That is a decentralized image sharing platform, basically an Instagram clone called Decentragram. So congratulations. You know, you've written a smart contract, you put it on the blockchain, you've written tests against it. You know, you have done React.js, you've used ipfs. This is an unstoppable decentralized application. And so if you want to take this to the next step, there's a lot of things you could do. You could basically, you could put the front end, so this React.js application, you could put it on ipfs as well, and so that other people aren't accessing it like, you know, on a centralized web server. You could put it on ipfs, so it's a truly unstoppable application. You could add more features to the smart contract, all that kind of stuff, okay? But this is definitely, you've made a ton of progress in this video. So there's lots of things you can do from here. So, you know, of course, what you can always do is, whenever you create your project, you can tag me on Twitter and, you know, share your project with me that way. I can be sure to share that out to the world and show people what you've been working on. And, you know, as always, smash the like button down below. That really helps the YouTube algorithm surface these videos so that more people can find them. And if you want to take the next step, like, and really learn this stuff even more so that you can land a high-paying job, become a freelancer, you know, build your own project, then you can just head on over to dappuniversity.com/bootcamp to get started today. I can show you how to build a real-world blockchain application, not just a tutorial, but a real-world app for your portfolio, so you can land that job, become a freelancer, you know, build your own app, whatever you want to do. All right. So that's all I've got. Hope you like this video, and until next time, thanks for watching Dapp University.